Okay, so on this video, I'm going to recap graph transformations for trigonometric ratios, and then we're also going to have a little look at modeling questions where we are modeling a situation using a trigonometric graph. So, first of all, here I've got some graphs I'm going to go through, and I'm also going to state what the maximum and minimum of the graph is. Now, all of these I've done are from sine, so let's just make sure we're really clear on what the sine graph looks like. So remember, it goes on forever. I could have also gone over with negatives. One full loop is done every 360 degrees. That's 180, that'd be 90, that'd be 270. It currently has a maximum of 1 and a maximum of -1. So here, 3 sine x, well, here it's outside the function, so that's going to affect the y values. It's going to be stretching it this way, so it's going to generally look the same, but its maximum now is 3 and its minimum is -3. I'm probably just going to from now on just draw one full loop from between there to there. Let's see. So here, sine of x plus 30. So this is inside the function, so it's going to affect the x coordinates, but it is going to do the opposite of what it says. So here, adding 30, in fact, is going to take away 30, it's going to shift to the left by 30 degrees. So here, this is going to shift over slightly, so it's going to start at -30, but it's still going to have that looping system where here, instead of being 180, this one crosses at 150. Instead of being 360, it's going to cross at 330. This has only shifted it to the left, so it's still going to have a maximum of 1 and a minimum of -1 here and here. So 1 plus sine x. So again, this one is outside of the function. I have not given myself a lot of space here. This is outside of the function. So this is going to affect the y value. So it's going to do what it says, and it's going to move it up 1. So instead of starting at 0, it's actually going to start at 1. And it's going to go up and down. Not my greatest graph there, but here it's going to do 180 degrees is where it gets to this little middle part here, and it will get to that part at 360. So we started at 1. It's going to go up, still up 1 to 2. That's a terrible graph because that should be reaching the axis. What am I doing? Let's do that better. So it's going to start, the center point here is going to move up 1. It's still going to go up 1 and down 1 from there. So it's going to reach a maximum at 2, and its minimum is going to be at 0. That's why my graph was terrible there. So, and on forever. So here it's going to reach that maximum beforehand was at 90. It's still reaching it at 90. It's going to go back to 1 at 180. It's going to reach its minimum there at 0 at 270, and it's going to get back to 1 at 360. Here, 2 take away sine x. So this one is a little bit tricky. Here, we've got 2 changes. So it's going to move up 2. So instead of starting at 0, it's going to start at 2. It's going to go between still here sine x, so it's only going to go up and down as far as 1 either way. So that's going to be between 3 and 1. But because this is now take away sine x, that's sine x has been multiplied by -1. So that's going to affect the y values. That's going to be a flip around. It's going to be, instead of going up first of all, going down. Like this, where that point is still going to be 360. So again, because that's negative sine x, that's flipped it around. Okay, let's stick with doing two different things to it. Here, 5 plus sine 2x. So this means it's going to go up 5. So it's going to start at 5. And now this time I'm multiplying it by 2, but this is inside the bracket, so it's going to affect the x coordinates. It's going to do the opposite of what it says, so it's going to actually divide it by 2. It's going to shrink in. So instead of it doing the rotation within 360 degrees, it'll do a full rotation in half that time, so 180. There'll be 2 full sets of rotations in 360 degrees. So it's still going to go up by 1 and down by 1, so it's going to be a maximum of 6, a minimum of 4. But again, the speed at which it does this is going to be twice as fast. So one full go round, so that's to there. That usually happens in 360, but this time that's going to be 180. And then another full go around there is going to be 360. Okay, 3 different transformations. Here, I've got 3 take away 2 sine half x. So here it's going to move up by 3, so it's going to start at 3. I've got sine is going to be multiplied by -2, so that remember that negative is going to flip it around, but also it's going to get stretched by 2. So instead of going up by 1, it's going to go up by 2. Instead of going down by 1, it's going to go down by 2. So this minimum is going to be between maximum of 5, minimum of 1. Half x, so that's affecting the x values. It's not going to half it this time, it's going to expand it out. So it's going to do half as many revolutions within 360. I'll have to do a full revolution in 720 degrees this time. So remember, flipped around, so it's going to go down first of all towards 1, and then up, and then, so that full revolution there from going down and up, that is actually going to be 720 degrees. Here it has done half of it in 360. So hopefully that was just a quick recap. Let's talk a little bit more general now. So let's say I've got 3 different transformations on the cos graph. I've got A plus B cos CT. So here A is going to move it up or down. B is going to be a vertical stretch. I have misspelled stretch there. I'm still not certain if I've spelled it correctly. And C here, inside the bracket, is going to be a squish. So here I'm talking about moving it up or down. I'm talking about having a stretch and also potentially a squish. So if I was to plot 4 plus 3 cos 2t, remember cos is a graph that starts at 1 normally. Then we'll go minimum of -1. Here, 180 in the middle, and 360 at the end. So 4 means that here the center of the graph is going to move up 4. So it's always best to think about it in terms of the center of the graph as opposed to where it's starting. So here the center of the graph is going to go up 4. So 4 is the center of it. Now here it's going to be stretched by 3. So here this is usually, it goes around the center, goes up by 1 and down by 1. So instead this time it's going to go up by 3 and down by 3. So we're going to be having a maximum value of 7 and a minimum value of 1. And here the 2t is going to be a squish. So instead of it doing a full rotation in 360, it's going to take 180. It's going to squish it in. It's going to do that in 180. So it will do 2 full sets of that in the 360. So here, remember, center of it is gone up to 4. So I'm starting at the 7. It's going to go down around that center and back up. It's going to go down and back up. So that is 360. That is now 180. So it's been squished in I've done 2 full revolutions in 360 degrees instead of just 1. Okay, can we go backwards? If I give you the information from the graph, can you go backwards from it? That I have made a mistake on that. That is not what I intended to do. So, here, I'm telling you the maximum of this is 6, the minimum of 2, and the center of it here is around 4. I'm also telling you that this time it does 3 full rotations around in 360 degrees. And that means 1 full rotation in 120 degrees. So here is the center of it is gone from 0 up to 4. Well, that means that this is going to be 4 plus, again, something to do with cos. Now, in terms of how has this been stretched out, well, this is going 2 up and 2 below away from that center, so it's been stretched by 2. Here, it's been squished in, so it happens 3 times, so that's going to be 3t. Now, this kind of skill of being able to take that information of the middle of it, the maximum, the minimum, and how many revolutions are in that time is really important when we do mathematical modelling. So here, a mathematical model for a journey on the London Eye is h of t is equal to a plus b cos ct, where h is the height from the ground and t is time. So I've got the London Eye, which is just a Ferris wheel. You're going to go on it, you're going to go around the height that you are from the ground. So we're going to start off a little bit off the ground, and then we're going to track that height, how far you are away from the ground. So you're going to go up, increasing your height, then you reach some sort of maximum height, and then you need to go back down again. So it takes 30 minutes to do a full journey. You board 5 meters above the ground. The diameter is 100 meters. Find A, B, and C. So I know my initial height is going to be 5 meters. So that is the minimum height I'm going to have. I know my maximum height, well, if that has a diameter of 100, my maximum height is going to be 105 meters. And I know it takes 30 minutes to do a full journey. So I would first of all think of this in terms of the graph and then work out what the numbers are afterwards. So my graph for this where is the center of the graph going to be? It was always easier to kind of draw it around from where the center is. So I'm going to go from a minimum of 5 to a maximum of 105. Nope, I moved my paper. So I'm going to go between 5 and 105. So my center is going to be 55. Now, I know that I'm going to start 5 meters above the ground. I'm going to increase my height to the maximum of 105, and then I'm going to go down again until I get back to 5. So that is going to take me 30 minutes. Again, if I didn't get off, I could keep going forever, but I know this is sort of that one journey around. I start at 5 meters, I'm going to go up until I reach a maximum of 105, and then I'm going to go down again, and that whole thing takes 30 minutes. So here, the center of the graph has moved from 0 up to 155. So I know my graph has moved up 55. So it's going to be h of t is equal to 55 plus. Now in terms of what has that stretch happened? So usually from the center only goes 1 up and 1 below, but this time it's now gone 50 up and 50 below. So I know I have multiplied my cos graph by 50. Now, oh, wait a second, I've made a mistake. Hopefully you noticed that mistake before I did. this isn't a normal cos graph, is it? Because here I start by going upwards instead of going downwards. So I've actually flipped my cos graph. So that 50 is correct, but that's going to have to be negative. It's going to have to be negative 50 because the cos graph has been flipped around. Now, here, usually on a normal cos graph, that would be 360 degrees. But this time it's taken 30. My time is 30, so this is time. So how does that impact here? Well, remember from the previous question, it was important for us to know that this was how many times that full revolution around could happen in 360 degrees. So here, one revolution happened in 120 degrees. It has 3 times that can go round. This time I've got 30, so I'm going to have to do 360 divided by 30, and that gives me 12. So it's going to be 12 full revolutions. So that's going to be 12t. So my final answer there, A is 55, B is negative 50, and C is 12.